Okay, so after this, subtraction vectors. After this, you know how to subtract vectors. And even more important, be able to recognize a vector subtraction situation, which is quite challenging. So do pay close attention. Okay, let's join me here. So subtraction of vectors. Whoopsie, I went too far already. Subtraction of vectors. What do you think it means? I should have a look through and see what you guys have. Well, addition means to place tip to tail. Right? So subtraction. Well, let's refer back to what we know about regular scalar numbers. So the subtraction of scalar numbers can be rewritten as addition. Would you agree? Like for example, you have 10 minus 6 in front of you. Would you agree that you could write that as 10 plus minus 6? Same thing, right? 10 minus 6 is the same as 10 plus minus 6. So in reality, you can think about all subtraction, every subtraction that you've done right from day one, you can think of that as really adding the negative, right? And negative 6 is the negative or the opposite of plus 6. Okay? I can give you any number, you can give me the negative. 14. The opposite of 14? Minus 14, right? Just put a minus sign in front of it. Okay, so what do you think my next question is? I don't have the question. Okay, well, we'll just do it this way. What is the negative of a vector? What does it mean to be the negative vector? It's a vector having the same magnitude, but exactly the opposite direction. The negative vector is a vector having the same magnitude, but exactly the opposite direction. A complete 180, if you will. No joke. It's actual math. Okay, so what do I mean by all this? Well, if A is like that to the right, what is minus A? Same length, just to the left. If B is up and to the right, minus B is down and to the left. And I'll pause there for a second because I know people are jotting stuff down. If A is just reversed, B is reversed, what if I just give you the direction? What if I give you the bearing of 0, 1, 0 or 10 degrees? Negative 10 degrees? Good guess. 350. How'd you get that one out? 360 minus 10, I'm guessing, right? Yeah, is that the exact opposite? Isn't 10 degrees like that? Right? Bearing, remember 0 at north, Savannah? 0, 90, 180, 270, remember that? Okay. Oh, so where'd you get the 190 from? Exactly. In fact, pulling a 180. That's what it means. It means go in the opposite direction. So Colin just took 10 and added 180 to it and got 190. And I wrote it really badly. Yeah, so the opposite of 10 would be 190. Okay, now what if it's more than 180? What if it's 300? How'd you get that? Now, what do you think? Don't know? Well, where's 300? There's 270, right? So 300 would be there, so it's got to be like this way, right? Pull a 180. Instead of adding 180, so 300 minus 180, I think it would be 120, right? So what's the rule? If it's less than 180, you simply add it. If it's more than 180, you subtract it. It's not hard, right? Here's one more. What if it's south 15 east? South 15 east. Well, the opposite's going to be exactly north 15 west. That's almost the easiest one. All you do is just change the directions, the letters, right? South becomes north, east becomes west. It's pretty easy. Pardon me? It is for clickers. So, I sort of gave you how it works. Let's see how you do. Question number 1. What is the negative of 10 meters per second east? Is it minus 10 meters per second, 10 meters per second west, 1 meter per second west, or minus 10 meters per second west? Ooh, could be tricky. Read carefully. Answer. So those people that are following at home, answer is B, 10 meters per second west. Okay. So vector x is 25 kilometers an hour at north 30 east. What is minus x? Okay, let's see how we did. Yay, we got it all right. North 30 east becomes south 30 west. Just change those letters. That's all it is. Okay, so to subtract vectors, what you do is find the inverse of the vector to be subtracted. Find the inverse, find the opposite, and add it tip to tail to the other vector. Just like you did with 10 minus 6, right? I said 10 minus 6 was the same as 10 plus minus 6. Same thing. A minus B. No longer a clicker. This is notes. So A minus B is simply A plus minus B. A plus minus B. That's all it is. It seems hard, but it's not. Oh, at least we can get it all decided. A plus minus B. Do I have a thingy? I do not. Okay, so how do we do this? Do you guys have that picture there? You have to draw it? Okay. To subtract vectors, find the inverse of the vector to be subtracted and add it tip to tail. So, if I'm going to add here, I'm going to go, if that's B, then that's minus B. And all I do is, there's vector A, here's minus B, right, and I just add it together like that. There's my result. That's it. That's all I did. Which one did I flip? You were watching, Tara, when I did it. I know. I watched. I watched you not watching. I took A, and I made a copy. And then I took B and made a copy and added it tip to tail, and there's my result. Okay? You will notice that it's the same as if I had put them tip to tip. If I put them tip to tip. But I prefer you guys think about this negative stuff. And that's because I'm setting you up for grade 12. Okay? So it's A plus minus B. That's it. That's it. Can you do that, Savannah? Flip and add, right? That's all it is. Okay, so shall we try one? If A is 10 meters north and B is 50 meters east, what is A minus B? Well, I would like you to, when you're doing something like this on a test, to demonstrate that you understand about the flip, I would like you to show me A plus minus B. Show me that. That way I know you know the whole flip thing. So 10 meters north and 50 meters east, right? A plus minus B. So it's going to be, A is going to be 10. And then B, instead of being 50 meters east, what's negative B going to be? 15 meters west. So then just add them together. Yeah? Well, that's the verb, isn't it? That's the noun. In Canada, we have two. I'll explain in a bit. Let's worry about this now. So I've gone 10 north, and I've gone 15 west. Why west? It's the opposite of east. Now, lots of students want to flip either both of them or only one, but they flip the wrong one. Which one do you flip? The one that you're subtracting. You flip the one that you're subtracting. Now, is this a right triangle, Annika? Can I use Pythagoras? I can. How come? Because it's a right triangle. R squared equals 15 squared plus 10 squared. Fifteen squared is 225. 10 squared is 100. So, this one. I can't do square roots in my head though, unless they're like things like 9 or 16. Someone want to help me out here? It's probably like 17.8 or something rather. Square root 325. 18? 18.0? 18.0 what? Meters. Not worried about it. Am I done with that? How come? Exactly. Got to find the angle. Which angle? The one from where you start. Inverse tan. Tan minus 1. Inverse tan. Opposite. Which is 15. Adjacent, which is 10. Inverse tan 15 over 10.
So it's not supposed to be 10.
So, for those people following at home, vector A is 5 meters per second north and vector B is 4 meters per second west. Which diagram best shows A minus B? Oh yeah, let's have a look. Correct answer? C. Why C? 5 meters per second north. It's A minus B. Which one are we flipping? B. So 5 meters per second north. That's A. B is 4 meters per second west. So that means that minus B is going to be 4 meters per second east. Right?
No.
Okay. How will you know to subtract? Here's the hard part. How will you know to subtract? There's a couple different ways. Number one, it says subtract. If it has a subtraction sign, you should subtract. Here's A, here's B. I'm not sure I got minus B here, but that's not right, is it? Let's see what this animation's doing here. I was taking my time, apparently. Is that as far as it goes? Oh, there we go. There's A. I didn't flip it, though, did I? I'm a bad guy. Oops. That one's A minus B, right? Yeah, it should be like this. Right? So you subtract when it says subtract. What's this one over here supposed to be all about?
So A stays the same.
Let me just play this all again here. What's going on here? Too bad it's so long. A stays the same. How come B gets flipped? Because that's the one you're subtracting, right? A minus B, opposite direction. Result, A minus B. That's right. Except that the B is pointing the wrong way here, though, right? No? Well, I put it in red there. I don't know what the deal is there. I guess I gotta fix that one. No. And there's even says there's two of these too. What's up with that? Okay. Here's the hard one. Okay, it implies subtraction because it asks for the wind or plane speed or current or boat speed. So I'm going to explain this. You maybe have to write some of this down, do you? Yeah. It implies subtraction because it asks for the wind or plane speed or the current or boat speed. So when you're talking about a plane, right? The plane is in the wind, so the resultant is equal to the plane plus the wind, right? The overall result. It's the plane speed plus the wind speed. Well, what if you write it like this, resultant is plane plus wind, but now if I'm solving for the plane speed, right? If I want the P all by itself, then the W has to go to the other side and it becomes, no, this is a plus W, so it's going to be minus. So plane speed is resultant minus wind. Right? Take that W to the other side, becomes negative, R minus W, which means that the wind speed would then be, these are all vectors, what would it be? R minus P. Okay, so if you're solving for the plane or the wind, you're going to have to subtract. If you're solving for the plane or the wind, you're going to have to subtract. How does that relate to boats in rivers? In currents. Same idea. Right? The resultant is the boat plus the current. Resultant is B plus C. So what would you write there? Resultant is boat plus current. So the boat speed would be the R minus C, or current is, yeah, boat science. Go ahead and do those first two practice ones. Let's have a look. So the first one here, we're going to go A minus B, so 35 meters per second north, B is 10 meters per second east. So it's A minus B again. I told you it's subtraction. So minus B simply becomes 10 meters per second west. I think everyone can probably do that, right? Okay, so now we're going to add A plus minus B. So 35 north. And then plus tip to tail minus B, which is 10 meters per second west. Right? Different color. There's the R. R squared is 10 squared plus 35 squared. That's past the extent of my brain. I get 36.4. That's going to be meters per second. Put an angle there, right? So inverse tan, opposite is 10, adjacent 35. Second function 10. And I get 15.9, or let's say 16. Right, so that's going to be north 16 west. How many people got that one? Hands up. Awesome. Azil, you get that one? Yeah? Okay, good. Okay, that's the easy one, right? Okay, let's look at the harder one. A plane needs to end up with a resultant velocity of 100 kilometers an hour. I tell you, this is the resultant. The wind speed is, I see that, it's the wind. What direction of speed should the plane take? I'm solving for P, right? So I like to write R equals P plus wind. It's a good way to sort of set up or frame your thinking. We're solving for the plane. So plane is resultant minus wind. right? Or plane is equal to resultant plus minus wind. Okay, show me that. Show me your thinking. Oh, okay, I understand what I have to do here. Now it's a matter of vector addition. R plus minus W. So R is this 100 kilometers an hour at east 30 north. So east 30 north, right? It's going to be like this, east 30 north. And then from there, we're going to go 25 kilometers an hour at north 15 west. That becomes south 15 east. This is the one you change. South 15 east. Something like that, right? But you got to do it by scale drawing. How come? Not a right triangle. Remember me ranting and raving about that? Not a right triangle. Or you get the grumpy phrase. I haven't printed stickers yet, Kat. Okay? Now, should I actually do that by protractor thing for you? Yeah? Okay. I think I have time. So, 1 centimeter equals, we got 100, we got 25. Let's do 10 kilometers an hour. 1 centimeter equals 10 kilometers an hour. So I'm going east 30 north. Draw a reference line. Protractor. East 30 north. Right there. And it's 10 kilometers an hour, so it needs to be 100. So that's going to be 10 centimeters long. Okay, there's our first vector. And then I've got to go 25 at north 15 west. North 15 west becomes south 15 east. South 15 east. South 15 to the east. And it's 25, so 2.5. .5. Okay, so now should I label this? Yes, R, this is going to be minus W, right? So now I got to take my ruler here. Looks like 9.7, which would be 97 kilometers per hour. Right? 9.7 times 10. And my angle is 16 according to the protractor here on the ruler. So that's going to be east 16 north. How many got that one? A little harder. Right? Should you practice? Probably should. How do you know if you got them right? Got the link. Go and look. Okay, I'll give you the rest of this time. Probably give you some time to work tomorrow as well. I got to do the word problem stuff, which is kind of like this. But yeah, we're aiming for a test here. I know it's Tuesday already. Possibly Friday. Friday, it's the last day of the week. Can we do it on Saturday?